going to talk about this week is how clouds form. So we have a couple of terms that we're going to go through. So this is latent heat. So I have a graph that you're looking at, and this graph is showing you that from 0 to, negative 100 to 0, this line going up, that's where if it's ice is heating up until it gets to the 0 degrees. Then here it takes all of its energy to melt the ice into liquid water. And then the liquid water heats up here, and then it's at the 100, so it's boiling. So it takes all this energy, doesn't change in temperature until it changes all to steam, and then the steam goes up and it has way higher temperature that's there. So what we're talking about here is saying that there's extra thermal energy in water vapor than compared to liquid water. So you can see it's much hotter, so it's going to have more energy. The molecules are moving faster. So if you think about a burn, if you get burned by boiling water, which either would be terrible, here it stays at 100 degrees when it's boiling, but when it's a steam, it can keep raising in temperature, so it's going to be much, much worse to get burned by that steam. So in air, water condenses, and what happens to all this extra energy, so you can see there's more energy here than there is all the way down here. So when that water vapor that's here condenses into water, it's got some extra energy in there. And so that extra energy is released and warms the air, and then that can provide energy to form clouds, and then also to make storms worse, like thunderstorms, tornadoes, or hurricanes. So when we're talking about all this latent energy, we're going to talk about how do clouds form. So number one, they have to be able to rise up in the air. And we know as something rises, it's going to cool off. And we can see that from our picture over here. So this is a parcel of air, just means a package of air. As that package of air rises, it's going to adiabatically expand and cool. Adiabatic is a process where the parcel temperature changes due to an expansion or compression, but no heat is added or taken away from that parcel, and it can be either heated or cooled. So here's our picture. So you can see that when it goes up in the atmosphere, that parcel of air gets bigger. So here's what it is here, and now it's got bigger here, and now it's gotten even bigger as it gets higher up in the air. So it gets bigger, but at the same time, the temperature is decreasing. So makes sense. Your graph that you did, you should show that the temperature decreases in the troposphere, where we have our weather is. But what is happening to the air pressure? So is there more or less air pressure at the top compared to the bottom? There's less. So with less air pressure pushing down on that air, then that air gets bigger, it expands. You're looking at the opposite way when that air goes down. If it's pushed down, like in a high pressure area, so high pressure pushes that air down, it gets squished together because there's more pressure pushing down on it, and it heats up because as you squish this air together, you're forcing those particles to bump into each other more, and when they bump into each other more, they heat up. We have two kinds of lapse rates when we're forming clouds. We have a dry one and we have a moist one. So this is when unsaturated air, down here, this is the dry one. So it's unsaturated, that the air could still hold more and more water. It cools as it rises, we just looked at that. And it cools at a rate of 10 degrees every 1,000 meters. So that's right. So 10 degrees every 1,000 meters. So it's a rate it's constant. So it goes up doing that until it hits the moist adiabatic lapse rate. That is right here, the level of condensation. We also can refer to that as the dew point. You learned this in the other video. Dew point is where water vapor condenses out to water, which makes sense because right here we have a cloud. So when you hit the dew point, water vapor is condensing around dust in the air and making a cloud. And this is saturated air now because it's hit the dew point and it's condensing, and it goes slower than the adiabatic rate at between 4 or 9 degrees. So the line changes. It's going slower as you go up. Right. So you have two things. We just talked about this as a review. So if you have adiabatic cooling, the air is going up, air molecules are spreading out because there's less pressure, and the temperature is going down. We said it's about 10 degrees every 1,000 meters. That's right. Adiabatic heating, it's descending air, it's going down. Air molecules are becoming more compressed because of increased pressure. It was getting squished together. The temperature went up. It went from 10 to 30. Oops, this is the wrong one. It shouldn't be 10, it should be 4 degrees. We won't worry about that one. 4 degrees, so it was slower. Remember, this one went 10 degrees every 1,000 meters. This one up 4 degrees every 1,000 meters. And so we have two kinds of air. So if you have a high pressure, pushing down, you're not going to have clouds that can form. So if you have stable air, that the vertical motion is inhibited, which the air can't go up, it gets stuck. Like here, it's got a ceiling on it. So the temperature of the atmosphere cools more slowly than with the increasing altitude than does the temperature of the rising air mass. So it's not cooling out very fast, it's staying about the same. So if there's not a big change in temperature, you can't have much cloud. You can get those stratus clouds we'll talk about next week. But if you have lots of rising air, like in this one, these clouds can easily form. It hits that dew point and they can see. So as it moves up, the air is expanding, it's hitting the dew point, and we have big clouds that can form. And these that we're looking at there are cumulus or cumulonimbus, and we'll talk about cloud types next week. And how do clouds form? Because they are condensing around dust particles or salt or ice that's in the air. And when we get big enough, if you have enough of these water vapor, remember H2O, so we have O is the red and the H's are that blue. If we have enough water around there, then we see a cloud. And sometimes we have precipitation from that cloud. So this is just kind of looking at this. Look at how big average raindrop is, 2 millimeters. But when you look at what is in a cloud, here's your dust and here's your average cloud droplet. It's much, much smaller. So eventually they get too heavy and then it falls as rain. But they also can form something called hail. I thought this was interesting. So we're looking at, here's a freezing line of this huge cumulonimbus cloud. And there are these updrafts and downdrafts with these arrows that you can see here. So they can be spun around in this cloud for a long period of time, creating hail. And you can see every time it gets spun up on here, another layer of ice is formed. So it kind of looks like a tree trunk. So depending on how long those hail droplets are there in the cloud, they can get pretty big. So that's it for the week here. You're going to watch 2 short videos on how clouds form. There's 6 questions on it, and then you're done for the week.